I'm Imtiaz Rangwala. I'm a climate scientist. I work at this federal building, NOAA, here in the background. I am actually associated with the University of Colorado at Boulder. And I was born in India, and I went to schooling there and did my undergrad there. So I was trained as an engineer, and then I was always interested in environmental sciences. So I came to the U.S. To Rutgers University and to basically do a master's in environmental sciences. And then I just got very interested in this whole sciences related to our planet, which we call the Earth System Sciences. And I just decided I'll do a PhD. Basically, I found a good professor who was researching climate change, and I was interested at that time in the whole topic myself. And so, long story short, I actually ended up doing a PhD in the field of climate change, climate science, with a focus on high mountain systems and how climate is changing there and how it may change there, and if these mountain systems are more sensitive to climate change.
What would the Earth be like without the greenhouse gases?
Very, very cold. So where we're sitting now, it would be really what the temperature would be in the Antarctica right now here. So really very cold. They say almost minus, it was 50 degrees Celsius below, so more than 70, 80 degrees Fahrenheit below what we are experiencing right now. So very, very cold.
Mm-hmm.
That when we run our climate models to look into future, how the future would look like, and these are run at very coarse resolution. By that means, I showed you guys earlier about that climate models are doing all kind of, simulation of mathematical equations on a grid scale and kind of modeling all the processes that happens within a grid. And a grid could be anywhere from 100 to 200 kilometers or 300 kilometers. Big. And so, Colorado could be in just a few grids, the state of Colorado. And downscale is not easy. People use more complex models, so they get the information from the bigger models on the side, and then they run these very fine scale models within it and see, what will be the response in these fine scales. So, across this set of mountains, is there a difference? And it requires a lot of computation powers, a lot of money, So it's to run the models, if you want to run the models. People also do what they call statistical downscaling, so they establish relationship between large scale parameters and fine scale parameters, and just see if this changes this way, how will this change? So
Imtiaz traveled from Indianapolis to the Rocky Mountain to research weather data.
I basically came from India, and after finishing my engineering, I wanted to do, environmental sciences, and so that was my big travel. And I worked on a lot of regions like the Tibetan Plateau, the Rocky Mountains. So never got a chance to go to Tibetan Plateau, but I actually went. I am in Rocky Mountains now, but during my PhD I was in New Jersey, so I actually did go to the Rocky Mountains during summer, and one summer I did some internship out there. Okay, so this is what we call Science on the Square at this building of NOAA. We also have what we call Science on a Sphere, and really we're trying to show some part of real-time weather. Most of it is usually focused on the U.S. and we are concerned with the U.S. But also there's stuff This is where you see the Antarctica here and the South Pole, and you see the polar vortex here around the South Pole. And you know, these are showing different data, and so you can actually read what different data they're talking about. Talking about wind speed, they're talking about the geopotential height of different layers of the atmosphere, talking about sea level pressure. So you can get all these data, and all of these plots are showing that.